All right. Hello, everyone. It's so great to see so many people at our meetup. I think this is amazing. My name is Daria. I'm Flutter and ex-Android developer from Chile, and I will be your host today. So, why are we doing those meetups and what are they about? So basically, we want to connect local mobile developers because we ourselves are really passionate about mobile development and software development in general, and we want to share this knowledge, inspire you to share this knowledge also with us, and communicate. And when I say we, I mean Chile Labs, the host of this event. So we are a mobile agency, the best one in the Baltics, and we focus on both cross-platform development with Flutter, as well as iOS native, Android native, and we also can audit and test your code. But not only development, we have an amazing team of award-winning designers. We do mobile design, web design, and design review, and much more. Okay, and before we proceed, I want to do a little warm-up and put your hand up if you're a Flutter developer.
Ooh, not bad.
Okay, cool. And if you're not yet a Flutter developer but interested in Flutter development in general.
Very good.
Okay, also good. And native iOS developers? Okay, proud ones. Okay, I see that. And native Android developers? Okay, cool. So we have kind of 50-50, so that's great. Yes, and also we are always hiring. We have a list of careers which you can find on this website. But the most wanted Pokemon right now is UI UX designer. Probably there's none here. If there is one, I have a question to you. But if your friend is one, or you know someone who's in search for a great position, you know where to send them. Okay, and the agenda for today's, which you probably already know, but first will be a talk by Cagatay, who came to us from Finland, and he will deliver a great talk about architecture for Flutter apps, but not Flutter apps, but I won't spoil it. And then we will have a coffee break, and after that, next amazing talk by Max about building frameworks for iOS, and a little networking time, and beer. There's alcohol and non-alcohol, so whatever suits you. Okay, Cagatay, let's welcome Cagatay. And
Full screen.
Full screen, how do I launch it full screen?
So when I switch to the demo,
Yes,
you can help me with the visor. Yes.
Yes, okay. So how do we put this full screen?
Comment it off.
Oh, perfect.
Got it. Okay. It's recording. Good. Hello, everyone. It's amazing for me to be here. I would like to talk about Flutter today, but before that, a little about me. How many people use Wolt here? Okay, so you know Wolt. I don't need to introduce Wolt. But I'm from Turkey. I studied telecommunications engineering. But it was not for me. I realized it when I was doing master because I really wanted to be closer to the end user. That's why I switched to mobile apps, and Bluetooth apps was a bit related to the telecommunications. It was a good opportunity. And I did my master's studies in Aalto University in Finland. My master topic was Bluetooth applications for Android phones and iOS phones, and I found a job for smart locks, building mobile apps for smart locks using Bluetooth. And I had some short startup experiences. And then, anybody know Suunto? It's Finnish brand. Yeah, if you are running, doing outdoor sports, Suunto is there. There's Sports Tracker as well. It's how I started running, then I became ultra runner. I started with 6 kilometers when I was testing the application, and I finished 120 kilometers in 24 hours. So I was quite a tester and happily using the product for 4 years. And it was the first time I was in a big team. Then COVID hit. I started to do consultancy. Then I switched to Flutter because I had so many side projects, and I wanted to do apps for iOS, iOS and Android together. So that's how my cross-platform story started. I had several options: React Native, Flutter, and iOS native. Then I got a job offer from a company told me that if you don't know Flutter, it's okay. If you want to learn, yes, just join us. And I joined. It was a startup company. I worked there for 6 months. Then I wanted to work in a structured company, bigger company. I joined Wolt as an Android developer 2 years ago, exactly 2 years ago. Today is my anniversary at Wolt. And then we had small project for Flutter, which became huge, and I will talk about it in the next slide. So I'm full-time doing Flutter now at Wolt. So today's content is about architecture, but the motivation behind it, we will start it with that. And then the principles, because the principles lead to good architecture. Then I will show you a sample app, which is my side project, which is based on this architecture. And then I will talk about layered architecture. Finally, the very famous topic for Flutter, it's state management. We will talk about these things. So the business motivation, but before that, I would like to talk about what we do, how we use Flutter at Wolt. So at Wolt, we have many projects, like around 60 teams, I think. But there are 4 main apps. There were 4 main apps. So one is the consumer app. It's native Android, native iOS, because we want to get the maximum of the native experience, because we have budget for native development. And then we have Courier app, which is React Native, but maybe not React Native in the future. Let's see. And then we have native tablet app, iOS. It's in restaurants. When you make an order from a restaurant, you accept it with a native iOS iPad tablet app. And then we have Picker app, which is a Flutter app. So when you make an order from a store, the pickers picks it from the shelves, your order makes it ready, and then couriers picks it up. So this app is Flutter. And it started with 2 developers, used in 23 countries. But then there was a problem with this native app that the restaurants were using, because iPads, they're expensive. So not every restaurant could afford it. And then we wanted to provide an Android version of it. So we had 2 options, either joining the forces with the Flutter app or making the native Android version of that app. And then it made a lot of sense to join the forces with the Picker app. Then we deprecated the native iOS app and then added the missing features to this app, and this app becomes the merchant app now, which means that we had iOS developers, native iOS developers, and they joined our Flutter team. They started doing Flutter. It wasn't easy, but we did it. So let's continue. Why? Yeah, actually, I forgot to change the slide. So this was the Picker app, and it became the merchant app. Now we are doing this responsive design so that the tablets will be used in the restaurants with the Flutter. Business motivation. So why I'm talking about architecture now? Because when we onboarded iOS developers to the Flutter team, of course it wasn't easy, but we managed it, and our lead engineer told us that I want you to write an RFC, which is going to show like how is the app is implemented. So, and why? Because we want to have mutually agreed, consistent, and clearly documented architectural decisions. Onboarding new devs, we will have other devs as well, but we will have iOS devs joining our team. So we want an architecture easy to understand. So when we have a new team member, how long does it take to make a full feature, like implement a full feature, merge it? So this is a criteria for a good architecture. And then it should be easy, straightforward to add new features. The architecture should be easy to understand. Also, there will be 2 different teams now, one focusing on restaurants, one focusing on retail, so maybe some other configurations as well in the future. There will be more than 1 team for sure contributing to the same code base. So we need a good level of abstractions. The different teams touch different parts, and then we don't have conflicts. But also, due to abstraction, we will have a very good testable app. And testing is really important, because if this app cannot accept an order from Wolt, it cannot make money. So it's very important. The quality is really important. Finally, multiple teams are contributing to the project, so the abstraction should be done in a really good way that there won't be conflicts, so that there is one class and multiple people from different teams are joining to the same. It's very unlikely. It should be very unlikely if it's a good architecture. So these were the business motivation. From developer point, we want a maintainable application, Flutter developers, because like in the second half, in the end of the first half of this year, Flutter will no longer support the applications that doesn't support null safety, for example. And from maintainability point, we need to keep our app up to date. And extendable, we are going to constantly add features. We really need a good architecture, so it's easy to add new features. Readable, easy to understand, so that developers, it doesn't take long time to add a new feature to the app. Testable, quality is very important. So we want these things in our... But principles, a good architecture, having principles is really important. We already know these principles because they come from the seniority years of experience. But let's review those principles that leads to a good architecture. Have you heard Yagni? Yes. You ain't gonna need it. So it's usually when you are a junior, you want to, or you just join a company, you want to, like you take a feature and then you decide, okay, there is this feature, it's not in the description now, but I'm gonna add it. No, you only need to implement what is required, because every extra line of a code is in the feature tech debt, and it is potential to bugs. So just implement what is needed when you need it. Don't implement for the feature. Yagni. Second one, KISS. No, you know KISS probably. Keep it stupid, simple. So there is this comparison between simple, boring, stupid versus complex and clever. It's again like when you, there's this cartoon, it's really funny. So in the first years of your software development, you really want to use all these patterns, inheritance, abstractions, show like I'm so clever, but in the end you understand that the simple is better so that I can understand it in the future. So instead of instead of complex clever, simple boring is more valuable. But it doesn't mean that you shouldn't use the cool features. But the goal is that it needs to be simple. And this simple is really ambiguous and sometimes subjective. But the goal is readability and maintainability. We want this in the architecture. So let's have a look now, these two code snippets. The one in the top, a few seconds I'm giving you to check. Which one do you think it's easier to read, or it's simple? Second one is simple. It's coming with Dart 3 in the second half of the year, but I discussed this with my friend who is doing iOS development. He thinks that it's not. It's the first one is simple. So these things are ambiguous. So what is simple, what is not? Principles, they're ambiguous, subjective sometimes. Another thing is dry, don't repeat yourself. So this is really important from testability and maintainability point. So every piece of knowledge must have single, unambiguous, authoritative representation within a system. This is don't repeat yourself. Instead of duplicating, encapsulate it in a construct, in a method, in a class. And in this construct, this is the single authority, and reuse it. And any other part of the application should reuse that part. Why? Because maintainability, if something is wrong in that part, you need to fix it in all other places. And from testability, testing one single authority is much better. And if something is wrong, again, like the other tests will fail, it will help us from testability and maintainability point. So separation of concerns, this is the most important principle of layered architecture that we will discuss today. So each section in the code base has identified responsibility, And this enables us modularization, encapsulation of the implementation details. We will come to that with the interfaces. For example, if you are using Firebase for example, storing data in the servers, it should be very, very simple to change it to the AWS, for example. And it should take only, if it is one file, sometimes it's one file to change it, if you have enough modularization or encapsulation. Readability, maintainability, testability, and extendability from these points. This is really important. Hollywood principle, have you heard that? Okay, do you know this? It's from Friends. So it is, don't call us, we will call you. So this comes from the principle that, okay, now I'm doing an audition, and you are deciding if I'm good enough, and then I'm asking you, so how can I know about this? So can I call you? No, they say that we will call you next. So this is the story of this, and it's also known as inversion of control. So it explains provide any kind of callback instead of acting directly. So this inversion is used a lot in software language. It's usually refers to the delegation. So this is also like a story. For example, you are in this room, and then you drink a cup of water, and then you drink it, and then you leave it on the floor. You have an option. You have a waitress, and she brings you the cups, and when you finish it, she takes it and takes it back. That's done. So from like clean, like each one is easier. Of course, when you delegate it to that waitress. And this is actually, we are going to talk about this when we talk about state management. So instead of doing everything, we need to delegate it to the frameworks, libraries, some other classes. And dependency injection actually is one kind of inversion of control. And from testability and maintainability point, this is a good principle. Okay, now let's talk about the dependency injection. The goal is, when we are developing an application, breaking the large application into smaller pieces so that we can independently develop and test. But what is a dependency? Dependency that is an object required to perform tasks in a code section. So for example, that waitress is a dependency that is doing something, and we are injecting it to the room. A class should not control how its dependencies are instantiated. We are going to inject these dependencies instead of instantiating them in the classes. Yeah. So that we can easily test them with mocks. But yeah, let's go with the previous slide. I put this one because in Stack Overflow, you will see also an explanation about a dependency injection, how to explain dependency injection to a 5-year-old. This is a very famous story. So you have kids coming to kitchen after school. They need to study, and but they are hungry. So they can open the fridge and take things from there, take their food, drink, and yeah. But the food might be spoiled. They may break for example, the glass or anything. Instead, they are sitting, they are doing their own homework, their job, and what they need is brought by their parents. And here, the parent is the dependency injection. And this is how they are getting their work done, and then they get what they need to be able to do their stuff. This is how it's explained to a 5-year-old. And actually, we have libraries like Dagger in Android. In Flutter, we have Get It. So your parents are Get It and Dagger in this story. And then another principle is dependency inversion. This inversion is, again, here. It basically says, instead of concrete classes, depend on the interfaces, abstractions. So I'm going to talk about these layers. For example, presentation layer is dependent on the classes in the service layer, but they are not dependent on the concrete classes. In server repositories, for example, dependent on the remote layer and local layer, but they just depend on the interfaces instead of concrete classes. So in Catch, for example, you can use Hive library for Flutter. In remote, you can use Firebase, AWS. This service layer doesn't know about it, doesn't depend on Firebase. Instead, it depends on these interfaces. There's a contract between service layer and data source layer. Implementation layers are in here, so you are not actually using this Firebase. You are not instantiating in here. You are not instantiating Firebase class. So when you add your dependencies, you don't add Firebase dependencies in this layer. The dependency is in here, and this layer, the classes in this layer, uses interfaces, and that's it. So, and we inject the dependency here, but only the abstract interface is going to be used. Yeah, in short, high-level layers should not depend on low-level layers. We have the interfaces in the high-level layers, and in the runtime, these interfaces, the concrete parts of it, will be brought to you by dependency injection classes. And relying on abstract and interfaces makes API implementation swappable. As I said, here, implementation details are in here. You don't need to change anything in this class. You can simply remove the Firebase and then use AWS in here. For testability, it is important also when you are testing, you don't depend on Firebase, you just mock the interface that has the contract, all the information needed. Okay, that was the principles. Now let's go to architecture. So I'm going to show a sample app here. Daria, if you can help me, I would really appreciate. Because obviously I can't show you the source code of Wolt. I will show you the source code of my own app. How I do this. So, but first let me show you the app actually. Here. So what does this app do? This app is a negotiation teaching app. It's written completely with Flutter and using Firebase. So there are two apps. Let me show you. Yeah, there are two apps. One is the facilitator app. The facilitator app opens a session, and people in this app joins this session, and they receive confidential briefs, and they negotiate together. But there are two different apps. So we want people to install the Orange app, this Orange app, and then we only want to keep facilitated apps to the certain people so that only certain certified people can start these sessions. So I'm just going to make a quick demo about what this do. Yeah, this is a facilitator app. So I'm going to start a session. This is the cohort code. Let's start quickly this. And the session is started. Now I'm going to join here with this app. Yeah. Oops. Sorry. Yes. Now it's here. Yes. Yes, I'm joining here now. The session. 1, 2, 3, 4. Okay, this is a hidden now. I'm going to make it visible for participants. So one participant is here. Let's go to the other one now. The other app is here. One, two, three, 4. Okay, now we see it. 2 people are here, and then we create the teams. There is one buyer, seller. We sent the briefs to them. So now both have different confidential briefs. So let's start the session. Negotiations are started now. So I'm going to make an offer. So 400. And then let's accept it. And then you can give feedback. But you got the idea what the app does. So I'm going to talk about how I implemented this one, 2 different apps. Here, let me show the slides. Yes. So here, there are 2 different apps. One for production, one for development environment, made it 4. And with Flutter, now 1 code base, we have Android and iOS versions of it. So in total, 8 different applications. I already have CI/CD implemented for those, so it's not easy. It looks it's not easy, but with Flutter, it is really possible to do this simple and separate the concerns. So how I did this? I have this orange app and then this purple app, and then this is the common part. In this common part, I have, for example, authentication implementation, Firebase, and then common data models, dependency injection, and the common widgets. But in the app, actually, I have only presentation layer, widgets layer, service layer here, these 3 layers. And now let's talk about what these layers are. We will come back to that. So the layered architecture, we have layers. Smaller pieces are used to construct large application. What I mean by that? So we have the smallest piece, like a variable in a method, for example. And then we have fields, then we have classes. Classes come together, build modules, and multiple modules are in layers. And these layers have separate their own concerns. Layer is a logical separation of these concerns in the highest level. Usually it is 3 layers: UI layer, service layer, also known as repository layer, and then data source layer. But here I wanted to separate widgets layer and presentation layer because I wanted to separate view and view model. We will come to that. And in these layers, we have modules. They are smaller pieces. They encapsulate an execution. For example, one module could be doing AWS-related stuff. The other module could be Firebase stuff. There are multiple modules joining together, responsible of doing one, combining and becoming one layer. These modules are interchangeable. They can do the same things. For example, for database, you can use Hive and then just change it with shared preferences or SQL. And one or more modules may expose the same functionality. As I gave the example always, AWS, Firebase, and Superbase. There are different providers, the libraries, sorry. So this was the vertical layers, but these were features in the layers. For example, this one, in our example at Wolt, this is about, for example, menu operations. This is about accepting operations orders, and this is about picking from the shelves. And I have UI widgets in this layer. Their block classes are in this layer. Repository classes for these fields are in this layer. And then backend communication and local layer is in this one. So the layers are vertically listed and horizontally organized, but it doesn't have to be always features in layers. It could be also layers in features too. So in picking feature, for example, I have one module, everything is in one place. But I personally prefer features in layers because in this presentation layer, I have my own module. For example, let's see the code base. This is my presentation for Sopo app, for example. Now here, these are my dependencies. And all the block classes are here. See, like block. So if I change, for example, some this library here, or rxstart in here, I don't need to go every folder to change it. This is why I prefer this one. But this one is preferred because, for example, there are different teams, multiple teams, but teams are responsible for features. So they only focus on these features. It's a choice, but I really believe that it doesn't have to be separated really for every feature. You can because the features are already separated in this part. Higher layer can call methods in the lower layer, but the lower layers cannot call. For example, you can call a method in here from the block, from the V model, but the V model doesn't know that it is used by widgets or which widgets are using it. So the events are going from here, and data is going from here to here. Data flow is unidirectional. This is what I said. Actually, I'm going to repeat myself. Events are triggered from UI, going down to the data source, and then the application data flows from bottom to up. Layers are closed, meaning that you cannot communicate from widgets layer to service layer. It's only open to presentation layer, and presentation layer cannot connect directly to the data source layer, but it can only communicate the one below. It's closed. So this is architectural layers, but we have commonly shared modules as well. I didn't really put them here. For example, analytics can be in the service layer. Widgets, it can be in the presentation layer or widgets layer. So these are the modules that are open here, but I'm focusing on, from architectural point, these 4 layers. Okay, let's start with the data source layer. So data source provides an application data from different data sources. It's usually database or backend remote servers. But in our case, for example, we use printers as a data source. Or at Suunto, the watch was a data source because, for example, this is the source of steps. It is syncing to the phone. The phone is locally saving and updating to the servers. So when you open your account in another phone, you should be able to see this one as a single source of truth. When you have multiple sources, it becomes really difficult to orchestrate this. And we are going to drive the UI from these data models. And the data models actually represent the data of app. And they are independent from the UI elements and other components in your app, meaning that, like here we have, for example, I showed you a session in the previous demo app. So it's the business logic. So it's modeled depending on the user requirements, but the model in the widget can be different. And let's continue with the catch, which is the local module in your app. Why do we need catch module? First, we may want to access the data fast. You open the Instagram app. You want to see, as soon as possible, the latest post. And you're really frustrated because you were interested one that new ones are immediately came from the backend. So use the last copy of stored data. We share them in the catch. And not all data is actually generated and persisted in the servers. For example, you have brightness for your app as a choice. You might switch in the settings and just save it in the local data. And our app might require offline mode as well. So 2 ways to implement local data source. You save your data in files, database file, JSON files, or in the memory. So if you keep your data locally in the phone in the memory, you might run out of memory. The app might be terminated by operating system. Or if you choose, you can keep it in the files. When you open the app again, you can see the same data. Now let's talk about the remote layer. Is communication with the servers. You get the JSON data. You create data model specific to the remote layer, and then map it to the application data. OK. Here I want to show you something fast. I'm not sure about the time. I forgot to start it. So here in my app, I have, for example, the Firebase implementation here. Let's say the session. Yeah, so all the operations about the session are in here, and it's actually a Firebase, Firestore. But there are 2 interfaces here. Oops, this is big for some reason. Yeah, okay, not anymore. Okay, I got it. So, for example, this Orange app is you can only access these methods. It can listen to active session, it can add negotiators to the session, but the facilitator app can do more. Update the active session status. So all these interfaces are implemented in here, but in the end, the service layer in this app, let's continue. So when you have a good architecture, you know where your code is. It's very easy to navigate. So for example, this session, we are only in this service layer, we are only injecting this interface, and then in the facilitator, the other one. This is called interface segregation. Yes. And when I want to switch to AWS, I just need to change it in the base module here, the class. Yeah, anyway, the class is in here. Let's continue. The service layer. The service layer is a layer composed of repositories. But what is a repository? Repository is the orchestrator for data sources. So you got data, okay. So you are showing the user data in the UI. It is first getting from the database, and then you get the data from backend. Then the data is saved in the database, and then we again send the fresh data from database. So this orchestration is done in the service layer with the repository classes. It is the central point of the business logic, and it solves the potential conflicts, as I said, like you have a watch, you have server, and then your local data. So you solve all the conflicts there, but important thing is that there is only single source of truth. So what you expose to the layers below, or sorry, above in this case, to the presentation layer, is only one data source, which is usually the database, the local data. And it exposes, okay, the data exposed from one layer to another layer should be immutable, and the data can be mutated only inside these layers. Let's go up. Now we are in the UI layer. I just want to be explicit about where we store the UI state. That's why I have separated widgets layer and presentation layer. And this is the very common thing about Flutter. You will see this everywhere. UI equals as a like F state, function of state. So your layout, the screen, is a function of the state. UI defined by the state, and the logic that produces that state. And this logic is inside this presentation layer. Again, UI state is whatever data you need in order to rebuild your UI at any moment in your time. We will come to that later. UI state is immutable snapshot of the details needed for the UI to render. And UI is a result of binding the UI elements on the screen with the state. So UI equals F state. This is Flutter's motto. In these UI layers, we have widgets and presentation. In the widgets layer, we have Flutter UI toolkit, Flutter method widgets. And then in the presentation layer, we handle the V model. Let's talk about the presentation layer. It holds the states and the state holder classes inside V models. And presentation layer have access to repositories from the service layer, provide states to the widgets. So the data from presentation layer to the widgets layer is only the state. Implementation, so the business logic actually is in presentation layer. And what is business logic? It's the implementation of product requirements, how the application data is created, read, updated, deleted. But in the widgets layer, we have Flutter UI toolkit and UI logic to compose the widget tree. If the UI logic doesn't require application data, then we use stateful widgets in Flutter. It's ephemeral state. And then what is UI logic? It defines how to display the state changes by composing the widget tree. OK, let's now focus on the MVVM. How long has it been? 10 minutes. Left. OK, great. So most important part of this slide is this MVVM. How many people are familiar with MVVM? Great. Most of Android developers know it. In Flutter, in iOS also there's this V model thing. But MVVM, if we in Flutter, there are very different state management solutions. You can apply the one from Android and iOS to the Flutter. Let's focus on this. What is model in MVVM? Model is the access layer, data access layer, and it provides the application data. So it is, in this case, the service layer. Once the View binds itself to the V model notifies the View. So here, V model is bound here with View is bound to V model, and V model notifies. And then V model calls the create, read, update, delete methods, and then model provides the application data. So what are these notifications? The notifications contain the application data from the model classes, but in a format presented by V model, so which is state, actually. Widget layer reacts to these notifications and compose a new widget tree. It can be one-off event or a state change. But now let's talk about the state management. So Flutter apps have thousands of widgets, and widget is just a unit of UI component. And as these widgets number increases, it becomes difficult to manage the state, because whenever the state changes, we rebuild the UI, compose a different widget tree, so many things going on the framework. But it needs to be done in 16 milliseconds to succeed frame per second, 60 frames per second, and 8 milliseconds to achieve 120 frames per second. So this means that Flutter actually provides you the algorithms that can achieve 120 and 60 frames per second performance, but it depends how you build your application, the architecture of our application. So if you have so many widgets, and if you build many of them unnecessarily, rebuild unnecessarily, then it will take longer time than 8 milliseconds, and you will not perform 120 frames per second, although your iPhone can do it. So this state management is about managing these rebuildings. And I use reactive state management. There are different solutions, and it is based on the streams, actually, asynchronous data streams. In Flutter, or in Dart in general, we use streams, but streams are not much used because they are seen as complicated, hard to manage. They might be closed or something. So, but I think it's useful. In the community, it's not much used, but instead there is this value listenable, value change notifiers. But this stream controller is very useful for reactive state management. So what is a stream controller? It contains a stream and sink. Streams controller exposes a sink so that you provide data, like an input. And then stream controller, you can add data, error, and done events. It knows if there are any listener, and it can close the stream. So this is a very common library that is used in the Flutter community. It's called Block. The idea is simple. Widgets sends events to the V model, to the event stream. It feeds the V model. Actually, Block is the V model here. And in here, the events are transformed to the state. And state the stream is exposed to the widgets. When the state changes, it rebuilds if necessary. Or it can listen to the events as well. But this is the short summary of block. In Flutter, we have this change notifier class that comes with the API. It is actually just a change notification API. It is very simple, and you can add listeners. You can notify the listeners. For example, here in the presentation layer, this change notifier comes from the API. Then you have base V model. Then your base V model has state and event inside it, and the screens extend the base V models. In the widget layers, we have a change notifier provider, which we provide these V models and add to the widget tree. Here, we are mounting the widget tree, the change notifier provider, and then create the V model here. So whenever a change happens here, it's rebuilt. And Flutter actually has this inherited widget. It's a low-level mechanism to provide this changes API. But we don't use it because it's complicated. And instead, we use provider library, which is a wrapper around inherited widget. So this provider library has this change notifier provider, and it is mounted in the widget tree. It listens for the notification. So here we have notify listeners. When it is called, you receive a notification. So whenever the state field in this V model changes, and if it is different, this notify listeners is called. And the change notifier provider widget itself becomes dirty, and it rebuilds. So UI changed, and when you have the new frame, you have a different widget tree. It is rebuilt. The UI changes. It's a bit details in here, but the logic is simple. So you have root widget, and you have screen A, and then you provide the V model with a change notifier provider. Whenever notify listeners is called in this one, this screen A is rebuilt. So we use context watch if we want to rebuild the widget. In this, for example, header part of it, and for footer part of it. But we don't subscribe in this, for example, the second one, then it's not going to be rebuilt. So we have elements to rebuild here inside change notifier provider. We register, and then we schedule a rebuild whenever notify change is called. This is a very simple demonstration. So you have your change notifier provider, which has a V model inside. In this widget, you call context watch, and you watch this V model. Whenever this V model changes, this is rebuilt. And then in this notification, you get a state. And according to this state, you build another widget tree here. And in this one, you can use context.read just to access the V model. And then you can call method. OK, let's have a close look again. This is the widget tree. In the widget F, you press this widget F. It's a button. And in this button, you access to the V model and then call a method from it. And in this method, you change the state. And then this widget C listens for these changes and rebuilds. When it receives the new state, it rebuilds according to this information. So, and then UI changes. This is very simple. Well, I said I'm a telecommunications engineer. This is like a state over time. State is continuous, which is state is in the time. In the time, this is the state, you can say. But then there are events that can trigger, for example, a toast message, a navigator pop. So events happens, they are one shot, and then there are states. Let's see now a little bit tweak from the previous block. So this time, we will listen for states and events, and then react to those, but it won't rebuild. Again, the same thing, like widget calls the methods in the V model, and then in the V model, according to the business logic, the state changes. Here, the state changes are listened with the change notifier provider. But here, we have a listener widget that receives events from the event stream and states from the state stream. And then, for example, does navigation or shows a snack bar. Well, this is a short summary of everything. So in the presentation layer, as I said, the Flutter framework provides you the change notifier. Inside this one, you can notify the listeners. But we have base V model, which has state and event streams. Then these are exposed. The screens, the V models of these screens extends this base V model. Here in the widget layer, we have root widget. Then we have V model. This listener, V model listener, listens, for example, the events, one-shot events. And here, listens for the state. And then here, just subscribes to the changes from state. Actually, that's it. How long has it been?
I think it was correct, but we started 10 minutes late, so
Okay.
10 minutes late, so all is fine. Thank you very much.
Thank you.
All right, so we have a time for a couple of questions. So, does anyone have any questions?
Well, it was a bit long. I'm sorry.
It's all right.
Yes.
It might be a little bit, I don't know, off there, but I mean, you come from Android native development,
Yes.
right? So you know clean architecture, right?
Yes.
It's basically also similar.
Similar.
Clean architecture has also mention of use cases.
Yes.
Do you in Wolt have any use cases, or do you just use repository and you want to
Yes. So we discussed it in the morning with
Wait,
the
please repeat the question into the microphone.
Okay. The questions was about the usage of use cases in the clean architecture. So we discussed this with Daria, why I didn't include use cases. Because this was a clean architecture, right? It's not very different. It's just I call it boilerplate. Some people don't call it boilerplate. It's necessary. But, I mean, for every single method, creating a class and exposing, okay, it's too much work to me. Instead of that, I put all the classes belong to a service in one class, instead of in the parameters, so putting all the use cases as a field and injecting them, I just inject the service for that, and then call the method in the presentation layer. That is the difference from the use case, from the clean architecture by Uncle Bob. Another difference with the clean architecture with Uncle Bob is I don't do data mapping when data goes from one layer to the other layer. Here, when data goes from, for example, catch layer to the service layer. So service layer has its own data model in the clean architecture. Presentation layer has its own model, and widgets layer has its own model. I think it's really a lot of work to have these models, and in most of the cases, they are very same. And if they are not same, I can create a model specific to the service layer. But clean architecture says that you need to have models, like strictly. So I'm just doing whatever is more convenient for me.
Oh, I see. You just don't need there's no need for use cases in your case.
In my case, I choose to group the methods that I need in one class instead of creating a class for every method. Yes, it is more cleaner, it's clean architecture, but I'm thinking like, what is the cost? It's extra code to maintain. So, and I'm really feeling like writing a class for just one method and then creating the interfaces and connections. It's really not necessary in my opinion. And we survive without it. Mm-hmm. Yeah, please.
I'm very new to Flutter, like unfortunately, and I use development as well. But you said the widgets like avoid redrawing them, right? But isn't it the same in Android native development? Like we need to avoid redrawing all the views and all the views here, right? It's basically the same idea. Right?
So the story is rendering pipeline. So it starts with the build phase, and you are responsible of the build phase. And if you have unnecessary builds, you will make your widget dirty, and then it will update the element, which is a term in the Flutter, but it will do extra layout, it will do extra painting. So in order to avoid these unnecessary steps, we just don't call the build method. So it is faster to draw the next frame. So one frame starts with build, layout, paint, and then composing the layers. And then in the next frame, but you have 16 milliseconds between them. So if you have many widgets to build, then it will take longer. Yeah. Yes, please.
Testing before or afterwards?
Ideally or in real life?
I mean, you were talking about so many microservices and so that I would say you are close to ideal, but you're not doing it.
Well, I'm starting coding and then I do the testing. I wish I would be the TDD person, test-driven development. I'm not. And I'm like, we are trying to increase our coverage, but also write unit tests. We are not aiming for 100% coverage. So yeah, I don't know. I'm sometimes feeling guilty to say that, but it works. How do you do?
I'm not a programmer, but basically, let's say I know what needs to be done because I have, let's say, the principles for TDD transferred to business development, and it works.
Yes, it works.
And you have described basically everything, but the question is...
I can actually do it if I want to. Like when I'm doing, for example, when I prepared my assignment for Wolt, I had amazing assignment, and I started with remote layer first, and then tested everything there, and then I did this one, and it was this module was compiling and tests were working, and then I added this one, and the last thing I added was the widgets. So you can do this, but in my daily work, I do the code first and then do the tests later. How do you do, Daria?
I'm not a TDD person. But yeah, I think I need to put my hands on code before I really understand what I need to test.
Yes.
Horrible.
Questions? Yes,
Maybe
please.
a question. Yeah, you mentioned you prefer all the features within each of these layers.
Yes.
And all the while, how important it is for an easy onboarding. But don't you think if you had everything featured first and all the layers within, then you only, because we saw the amount of code files you get, right? And in Flutter, it does seem that you get quite a lot of them. And wouldn't it be easier for the new guy if you just open your only
Feature,
folder,
yes.
right? And then everything is just there.
I understand your point, but isn't it also really simple to, like, this is just where the code is, right? So I have this app, and then I have my widgets layer, and I have the feature here, these exercises. And then I have presentation, and I go to lib. Again, I go to exercises here, and then the block is here. And in the service, I have the same. So it's like where the code is. But when I do this, what I gain from is each module has its own dependencies listed in here. So I don't know. What do you prefer, and what do you prefer? I understand your point from onboarding and from different teams. They focus on only modules.
They also work with multiple people with the same code base and do the merges quite more often because
Yes.
there's a lot less
Yes. And how do you do, by the way?
Well, we have not a lot of people working in one code base, so we basically do the same. But I do think that if your team is like 10, 20, and more developers, it's much easier, like feature-driven development.
Yes.
But it depends. I
It
mean,
depends.
it's always depends. So.
Yes, and I see your point, and I really believe that if you have different teams, you focus on that one. But exactly, sometimes the features are not really the full feature. You just touch the remote part of it. So at that time, again, it is only that part. When you have a task, actually, you just touch that part of the code. So, like, I'm not the same person with the previous year. I had very horrible architecture for it. Not horrible, okay, I'm not. Maybe 4 years earlier. But next year, maybe I will switch that one. It is just a preference. I learn by doing. I learn from the experience. And I would suggest, like if you're feeling comfortable, this one from onboarding point, and if you have really 300 modules and many people are touching the code base, that's okay. But in our case at Wolt, only 5 people are touching this code base. But from scalability point, you're right. Actually, our lead engineer is telling us to switch to this one because he is responsible of scaling. So we started the project with this one. That's why we are continuing with it. But from scalability point, maybe in the future we will need it, but it's not near future. And our app is not really that complex. It's not like Uber. This in native app, maybe it's a different story, but for a Wolt native app does so many things. But in our case, we have really certain use cases. Accept the order, do the picking, and then let the courier pick it up, and then inventory management. 4 things. So yeah, thinking about it. It depends. Like every question, the answer of this every question is it depends.
All right. Okay. So then, if you have any more questions to Cagatay, then we can do it there. And give me one more second of your time. So what I want to say is that we are launching Chile Flutter School. It is still in early stage, so if you want the first one to be to learn about program, launch date, pricing, and so on, please subscribe. Okay, and it's 7:40 now, so let's make a break for 15 minutes and be back here at 7:55. And also, one last thing is we have a Discord server for mobile developers Latvia. So please join. All of the information gets there first. So yeah, okay.